Alright, welcome to this quick video on just higher degree polynomials. We had worked a couple problems like this in class today, and I just wanted to make sure I review a couple of the problems before things tomorrow. And so what I have here is a basic coordinate plane. This is the y-axis, this is the x-axis. And what we're simply doing here is looking at some certain clues. This just describes the leading term, the front term, so it tells you kind of what the degree is, what the leading coefficient is, positive or negative, real solutions it has, and then we discuss imaginary solutions and relative migs and maxes, okay? So with this particular problem, it kind of gives you free will on how you want this graph to look, but it has to kind of go by, you have to use these kind of clues to help you decide on what it's going to look like. And so I'm going to walk you through some steps and some clues to help you figure out how you want it to look. Alright, so this is very just kind of understanding how a higher degree polynomial works. Obviously it's more structural than this, but again, we're just kind of looking at the leading term and how it really affects the graph. Okay. So first thing we want to look at is this, and I'm going to kind of do this in blue. This is the first thing you look at right here. Alright, give me a second here. This is the first thing we look at, the leading coefficient. The leading coefficient is positive, which means that our graph is going to end positive. Okay, we know it's going to end going up. All right. Then the next thing we look at is we say, all right, is it an odd or even degree? If it is odd, then they're going to end or kind of begin and end in opposite directions. So for example, it's going to go in this direction on the other side. Now understand, when I say it begins, I'm meaning that this is the beginning and this is the end. So you have to understand that our two arrows are going to go in opposite direction if this is an odd number. Okay, so the next thing I look at, I'm going to come back to degree, but the next thing I look at is the real solutions. I see there are real solutions, 3 real solutions. What that means is that there's going to be 3 points where it crosses the x-axis. Those create real solutions. So if I do that here, I'm going to draw 3 dots on the x-axis, and that's going to symbolize those 3 real solutions. So I've taken care of that. All right. Now I'm just going to go, my process is, well, I'm going to go through those 3 points like I have to. All right. Oh, that's bad. That's not good. I got to redo that one. Let's see here. I'm going to go through here, go through there, go through there. All right. Now I'm at a point where I've kind of satisfied the 3 solutions. I've satisfied the leading coefficients are positive, but now I notice that I only have 2 critical points. All right. I need to have 4 critical points because the number of critical points in the kind of the basic level we're working at right now needs to be 1 less than the degree. And so we look at that and we see, all right, I only have 2, so I have to create another 2 kind of critical points, and I have this graph right here. Now, your graph could look certainly different than mine. It doesn't have to look exactly like this. I mean, your loop could be down here, and you could have going up through the x-axis, but it has to satisfy the idea that there's 3 real solutions, has 4 critical points. All right, now we're just going to talk about those critical points. In this case, we have 2 relative maximum, means we have 2 peaks. There's 2 maxes there. Then we have 2 minimums. Here's a minimum here and a minimum there. So there's 2 minimums, and you'll notice that the relative maximum is add up to 4. And then you'll notice that are any of these relative maximum or minimums? Okay, so we look at it and we see that because it's going forever in opposite directions, there's going to be no absolute maximum or minimums. Meaning, is it the highest point on the graph or lowest point on the graph? In this case, because it's going in opposite directions forever, there's not going to be any absolute maximum or minimums. And you could kind of guess that because if this is odd, if this is an odd degree, that means there's never going to be any absolute maximum or minimums. Okay? So again, this is at a base level. We haven't talked about points of inflection, but we're kind of just getting a basic idea of higher degree polynomials. All right? So take your chance at this one, and I'll kind of work it here in just a second. We'll do this one in green. That green color is pretty. All right? So we start out, we look at the leading coefficient. It is negative, so that means it's going to end negative. Okay? It is even, which means arrows are going to go in the same direction, or like some of you said, create a U. In this case, it's going to create an N. All right, and so we have 4 real solutions. So I'm going to make 4 dots on the x-axis. That's 4 dots there. So I'm going to go through 1, 2, 3, 4. Now I count up my degrees or my critical points. So that's 1, 2, 3. And I need how many more? Well, I need to have 4 because of the fact there are 3, and I need 2 more to make up 5. Because remember, there are 5 critical points in a degree 6 polynomial. There's always one less. And so I know that I have to create a little loop here, which I do. And now I count up my points here. I have how many maximums? 1, 2, 3. 3 maximums, minimums. 1, 2. And do I have any absolute maximum or minimums? I'm going to call this one my maximum. Okay, so there is one maximum point, meaning there's a one high point in the entire graph. Now I didn't talk a moment about imaginary solutions. Right, now don't confuse imaginary solutions with the number of critical points. Okay, kind of a separate issue. It's more of the fact that we're going to kind of see how there's only 3 real solutions, and the degree tells us how many solutions there are. And so what we need to do is compensate for that difference. Because there's only 3 real solutions, I need to compensate. There has to be another 2 solutions, which I'm going to call imaginary. It's kind of like a default mechanism for the fact that we're short on the number of solutions we need. These 2 imaginary solutions, remember, they always have to come in pairs. Always in pairs. Okay, so let's give this one a try. You see it's got 4 real solutions, so to compensate for that different, it's going to have 2 imaginary solutions. All right, we can never have one imaginary solution, and some of the problems you'll recognize that it does have a problem. So hopefully this was a great help. Please come in for questions, and I'll see you tomorrow.